What we've learned already is that, for example, if I had y equals x to the power of 4, what we've realised is that when I differentiate this, okay, what happens is I get dy dx, I bring 4 to the front, okay, and I take 1 away from the power. Now, there's a missing part to this that we didn't need to discover until now. Do you see the way one of the x's technically went missing? You had 4 to the power of x, x to the power of 4, which is 4 to multiply by your. Now you only have 3 of them. Okay? So what happened was one of them went missing. And where did it go? So what happens is there's a spot in here that's you're differentiating. ddx means differentiate what's missing, okay? So that means differentiate the x. Now what happens when you differentiate x? You get 1. So you can see every single time it's going to be 1. So there was no point in us doing this because the answer is always going to be 1. Now I'm going to bring your attention to the question 13. Okay, question 13. Now look what happens here. Okay, y equals 3x plus 2 to the power of 4. It's sort of similar to what we had already, except instead of x you have 3x plus 2 to the power of 4. Now it behaves exactly the same way for the most part. The 4 goes to the front, so we're going to get dy dx equals 4. Like x, it's maintained, so you're just going to have 3x plus 2 to the power of 3. Now here's where the missing part comes in. The missing part is you got to differentiate what's in the brackets. You always differentiate what's in the bracket. Now what happens when you differentiate what's in the bracket? When you differentiate 3x plus 2, what do you get?
3
plus 3. Okay? So that means that you're going to multiply the back by 3. Alright? So that's how it differs from what we've done before. 3 times 4, 12. 12, 3x plus 2 to the power of 3. You happy with that? We'll do another one. Okay? Now, what they can do then next is they can really try and trip you up with different ways, okay? So, there's another way of doing the power rule, which is number 18. Now let me show you what happens to number 18. 18 is y equals 1 over... Now what does the square root sign mean again? What power is the square root? A half. So I'm going to change this to 2x squared minus 4x to the power of a half. Now, what I'd get you to do next is this. What happens when we bring something to the power of a half to the top? Comes to minus a half. So, for example, earlier in the year you did this. 1 over x to the power of a half. You brought the x to the half to the top, and it became x to the minus a half. Whatever is in the brackets to the power of minus a half. Do you understand? So y equals 2x squared minus 4x to the power of minus a half. Now, like the last question, we're now going to differentiate and we're going to follow the rules. Exactly the same way we did question 13. Okay? So, dy dx okay, dy dx ends up to be, bring the half to the front, or minus a half to the front, then becomes minus a half. Okay? What's in the bracket stays the same. So minus a half. Sorry, excuse me guys. So what's going to happen next is we're going to have dy dx ends up to be, bring the minus a half to the front. So we get is minus a half, and then we get this is maintained. You never change what's in the bracket for the chain rule. And then what do we have to do to the power? Take away 1. Minus 3 over 2. And then we finally have to, the hidden part is we're going to differentiate what's in the bracket. Okay, and when you differentiate what's in the bracket, what do you get? 4x minus 4. So now it's going to be minus a half times 4x minus 4 times 2x squared minus 4x minus 3 over 2. Okay? Now, You never ever multiply the two of these because the power is there. Do you understand? Remember when we did this in first year? You have to do your indices before you do your multiplication. So the answer to this has to be 45. 5 multiplied by 9. You can't multiply 5 by 3 and then do 15 squared. So for example, in a test, alright, if I do something like this, if I change this question to 5x to the power of, I don't know, 4. You can't say that's 5x to the power of 4. You're not allowed to multiply the two of them. So basically, the bracket with the power beside it is always safe. You never go near it. It's the stuff around it that you change. Okay, so right now what we have here is minus a half multiplied by 4x. What's minus a half multiplied by 4x? Minus 2x, and then minus a half times 4? 2. And that's our answer. Here's our answer right here. Okay? And that's it. Okay? One more?
Yeah.
One more. Guys, so if we look at this one here, okay, for instance, number 21. Now, number 21, if you're to split it in half, right down the middle, one half is the chain rule we just learnt. The other half is a regular one. Now, it's one number multiplied by another number. In each one of these, you're going to use the product rule. Everybody remember the product rule? So, you got to write down the product rule to start. Do I dx equals u times the v dx plus v times the u dx. Now, what you got to start off with is label one of them u and label the other one v. So, u equals 3x squared. Now, what's the u dx? 6x, okay? The next one is v is 2x plus 3 squared. What's the v dx? Now, this is what we just learned today. No. Remember, it's the 2 to the front.
2 by 2.
And then it's 2x plus 3 to the power of 1. Now, because it's the power of 1, the 1 doesn't exist, does it? We never put an x to the power of 1 as x. So, this is the one example where the power isn't interfering with you multiplying. If it's to the power of 1, it doesn't interfere with you multiplying in. So then when you multiply in, you get 4x plus 6. Now to finish this off, all we got to do next is the y dx ends up to be equal to u, which is 3x squared, times the v dx, which is 2x plus 3 squared, plus phi times the u dx, which is going to be phi times, what's phi?
2 3.
Oh, sorry, just give me a sec. I got it wrong. Sorry, guys. Yeah, sorry, the v dx is 4x plus 6. I was wondering about that. It just seems a bit on the, just seemed like you're going to get a cubic out of that, which seemed wrong.
Plus 2x plus 3.
2x plus 3 squared and 6x, isn't it?
Yeah.
Now, what we can do here is this. Multiply in 12x cubed plus 18x squared. We're going to square this out. So we're going to do 2x plus 3, bracket 2x plus 3. We're going to get 4x squared. It's going to be 6x plus 6x, which is 12x plus 9. And then all in one swoop, we're then going to multiply each of them by 6x to get 24x cubed plus 72x plus 54x. Wait.
72x squared.
72x squared, that's the one, yep. Okay. And then 12x cubed plus 24x cubed, 26x cubed, 18x squared plus 72x squared.
90x.
Sorry? 90x squared, and then 54 at the end, yeah? So that's our answer for that one. Okay. No, anything it's an acceptable answer, but what some people are saying is, well, I could actually just divide in by 6, okay, and an x at the same time. So you could get 6x bracket 6x squared 6 goes into that 15x, and then 54 divided by 6 is 9. Now, I'm trying to think of, believe it or not, you could actually break that down further if you wanted using the reference number. You could get a reference number of 9 multiplied by 6 is... Oh, sorry, I can divide by 3 again. Alright, perfect. So, I can divide by 3 again, take out another 3, and so actually the highest common denominator was 9, was it not? No, 18. It's 18. So, we take out 3. Okay, so now it's going to be 6x bracket 3 bracket 2x squared plus 5x plus 3. Now we're going to get 18x. We can try and factorize this if you want. So we can get 2x squared times 3. Oh, sorry, 6 is the reference number. 6 breaks up into 3 and 2 will do the trick. Plus 3 plus 2. 2x squared plus 2x plus 3x plus 3. Factorize 2x into x plus 1 plus 3 into x plus 1, and that will deliver us 2x plus 3 x plus 1. Now guys, there's nothing in that question to say that we have to do that. It's just to be aware that you can do it. So just for the upcoming questions, will you please, if you can factorize it, do it at the end, just in case the question one day says I want it in this form. So you have to know that it's on. Okay? Alright guys, moving on now. We're going to do probably one of the toughest questions in this exercise. Is going to be number 24. Okay? Now, number 24. Okay? Unlike the other ones, it's going to be a... Actually, I'm going to show you 2 different ways to do the same question. 2 different ways for the same question. Are you ready? Okay. Step 1. Earlier in the year, if I gave you this, okay, root 16 divided by root 4, what would you tell me the answer is? What's 16 divided by 4? 4. And root 4 is? 2. Let's look at it a different way. Excuse me. You can break it up into root 16, root 4. That's one of the surd rules. You can break one big surd sign up into 2 surd signs. Then root 16 is 4, root 4 is 2, 4 over 2 is 2. The reason why I'm showing you that, I intend to take the same principle into the next question. What I'm going to do is this. I'm going to break it into root x plus 1 over root x. Now, 2 different ways of doing this. I'm going to do it, the first way I'm going to use the chain rule. Second way I'm going to use the quotient rule. So I'll show you now. First way I'm going to do is the chain rule. Change everything to the power of a half. X plus 1 to the power of a half. X to the power of a half. Then, using my power of surds, what can I rewrite that as? X plus 1 to the power of a half. And x to the power of minus a half. Okay? Now that that's done, what's going to happen next is this. Okay? We're going to say u is what, guys? U is x plus 1 to the power of a half. Dan, what's the u dx?
Half by x plus 1.
Plus 1. Take 1 away from the power.
3 over 2.
Minus a half. And don't forget the extra part. What's the extra part? Differentiate the bracket, always. And what happens when you differentiate x plus 1? Differentiate x turns to? 1. Differentiate 1 turns to? So it's just multiplied by 1. And because it's multiplied by 1, you don't even need to include it there. Now, let's look at the bottom. V. V is x to the power of minus a half. Now let's find the v dx, which is going to be minus a half to the power of x to the power of
minus 3 over 2.
Minus 3 over 2. Okay, now we're ready to do the product rule. Everybody remember the product rule? Do y dx equals u times the v dx minus v times the u dx. Oh, sorry, plus v times the u dx. Okay. Now let's put in our numbers. Okay, lads, u is what to say u was again? Oh, x plus 1 to the power of a half. X plus 1 to the power of a half plus v. V is, oh sorry, dv dx. dv dx is a half minus a half x to the minus 3 over 2. That's all there multiplied by each other. Plus v, x to the half multiplied by the u dx, which is a half x plus 1 to the power of minus a half. Alright guys, now we gotta think long and hard about what we're doing here. Okay? Okay, here's what I'm gonna do. Okay, got it. Okay, what first thing we're gonna do is we're gonna break them back up into fractions. Okay, because I can't operate at the moment with what I have here. Okay, so I'm gonna have x plus 1 to the power of a half is still on top. Okay, I'm gonna put minus 1 on the top. Do you see where I'm getting the minus 1 from? Okay, is everybody happy with the x plus 1 to the power of a half? Now do you see this minus a half? I'm going to put the minus 1 on top and 2 on the bottom, because this is all multiplied by each other. Okay, and the minus a half has nothing to do with the power. It's minus a half multiplied by x to the power of this number, Rory. Okay,
so is that not minus 3 over 2 at the end for the on the top one?
no, it's minus a half. It's just minus a half. Okay, so what's happening next is I'm going to put the 2 on the bottom. Now, see this power? This power here. I can put that on the bottom as x to the power of 3 over 2. What rule did I use for that? The minus rule. So for example, x to the minus 5 is 1 over x to the 5. Okay? Now that that's done, okay, have I counted for everything? That's in it, the half is in it, and that's in it. So I'm happy with that at the moment. Now, I'm going to do the same thing this side. I'm going to have x to the power of a half on top. Now, the half, it's just multiplied by 1. Do I even have to put in that 1? No. It then is divided by 2. I'm going to put the 2 on the bottom. Now, see this power, see the way it's a negative power? Yeah? So what I'm going to do there? Just bring it down, x plus 1 to the power of half. Now look at this guys, okay? We're looking at common denominators here. Okay? Now, the common denominator, they both have a 2, don't they? So, basically, this one here hasn't got an x plus 1 to the power of a half. So I'm going to multiply top and bottom by x plus 1 to the power of a half. Okay? This one here hasn't got an x to the power of 3 over 2. So I'm going to put an x to the power of 3 over 2 on the bottom and x to the power of 3 over 2 on the top. Now you're going to see what happens here. Minus 1. These are the same number, aren't they? So it's basically the same as y to the power of a half multiplied by y to the power of a half. What's y to the power of a half multiplied by y to the power of a half? Y to the power of 1, which is y. Okay, so guys, this is going to be x to the power of half multiplied by x to the power of half is going to be x plus 1 on the top. Okay? Now, all along the bottom, there is absolutely nothing I can do with this power at this point in time. Okay, there's nothing I can do. Okay? It's still all these numbers here. Now, what's x to the power of a half multiplied by x to the power of 3 over 2? X squared, yeah? Okay. Now, finally what's going to happen here is we're going to have, we're going to multiply it out. And we're going to have x squared minus 1x minus 1. Okay, can't do anything with that whatsoever. And on the bottom is going to be 2x to the power 3 over 2. And then x plus 1 to the power of a half. And that's all there is. There's no way around that. Okay, now can we just keep this answer in mind, because I'm about to go through a different method for the same thing. Okay, so hopefully this second method might not turn out as bad. Okay, so we'll see now. Now my other option was, when I got here at the start, and I'm going to keep everything pretty much the way it was, bar v. Now I also have the option of what rule here, guys? What's the other option I have? I can do a quotient rule, and I can say that u is what is it again? U is still x to the power of a half. Du dx is still a half, x plus 1 to the power of minus a half. Phi has changed to x to the power of a half instead of x to the power of minus a half. dv dx therefore is a half x to the power of minus 1 over 2. We're going to do the quotient rule. Quotient rule is dy dx equals phi times du dx minus u times dv dx all over phi squared. Now it's our job to input everything in and see what we can do. So dy dx therefore equals, okay, phi times du dx, which is going to be x to the power of a half, multiplied by du dx, which is going to be a half, x plus 1 to the power of minus a half, okay, minus u, which is x plus 1 to the power of a half, and that's going to be times the dx, isn't it? So that's going to be a half x to the power of minus 2. Now, on first examination, it is not any easier than what we just did, is it? No. Okay, and what's phi squared, guys? If phi is x to the power of a half, what's phi squared? X to the power of a half squared, which is x. Okay, now guys, problem here is we're going to have a fraction of a fraction, okay, which is not what we want really. Okay, so what I'm going to decide to do here is, in a second, am I allowed to do this? Can anybody tell me? Am I allowed to rub out the bottom and break it into two individual x's? Am I allowed to do that, yes or no? So if you want to find out if you can do it or not, do something like this. 7 minus 3 over 2. We know the answer is 4 over 2. Is that the same thing as 7 over 2 minus 3 over 2? Yeah. It is. So that means you're allowed to do what I just did. Okay? Now that that's done, what we're going to do next is we're going to... can anybody tell me what is this next? Right, here's the next thing you need to know. What's 3 over 5 divided by 6? And the divide sign is here. The original line is there. What's the answer to that? It's 3 over 30, believe it or not. Because you're actually multiplying the two of them by each other. Or Rory, the other way we do it is like this. We bring 6 over 1, flip it upside down, and we still get 3 over 30. Okay, so with this in mind, look at what we're going to end up having to do here. Okay, x to the power half is grand, still on top. The half is on the bottom. This x plus 1 to the power minus a half, we can now put that on the bottom as well as power of plus a half. Did I lose anybody there? Okay, the x which was there now gets brought up and turned upside down to become 1 over x. Okay, stop there. Next part then. Now remember, this is a minus everything in here, so you got to keep it contained. Okay. Once again, what we're going to do with the x at the end is this. We're going to turn it upside down, like we did the last one. It's going to be 1 over x at the end. Now that brings us to what we're doing here with this stuff. The x, this is a positive power, isn't it? Positive power means it's going to stay at the top. Okay? And then on the bottom, the 2 is already on the bottom because it's a half, it's a denominator. And this x to the power minus a half, can that go on the bottom as x to the power plus a half? It can, okay? Now that we're here, look what happens next, okay? We're going to have, what we could do there is we can see this x here. What's x to the half divided by x? X to the half divided by x? 1 over x to the half.
Good morning, here today's announcements. A reminder to all transition years.
Continuing, okay. So what we're going to do next is, we're going to write this is now, it's now x to the half on the bottom. So it's going to be 1 over 2 to the power of x plus 1 to the power of a half, x to the power of a half. On the other side, it's going to be minus x plus 1 to the power of a half. And then what we're going to have is 2. Now what's x to the half plus x to the 1? 3 over 2. We're now going to do a comparison. Okay, now here's the comparison. Okay, this is my answer from the first part, right? This is my answer from doing it the product way. Now look at this, I really have to end this now, okay? So, what happens is, we've got to look at both of them. This has x to the power 3 over 2, this has x to the power half. Does anybody know how to turn that back into x to the power 3 over 2? Multiply the top by x, and multiply the bottom by x. And what happens when you add x to the power half plus x to the power 1? So, we can now rub that out, and put it as x to the power 3 over 2. I've now matched up the 2 and the x to the 3 over 2, which is perfect. This one here is lacking what? It's lacking x plus 1 to the power of a half, and this one on top, x plus 1 to the power of a half. Now we're going to get x minus, what's this going to be? X plus 1, means I made a mistake in the first one. Okay, and that's going to be 2x to the power of 3 over 2, x to the power of a half. And what's x minus x? Minus 1, 2x to the power of 3 over 2, x plus 1 to the power of a half. Both methods are right, but I obviously made a mistake here with this one. I got the same denominator, but I made a mistake with the numerator somewhere along the way, so I'm going to try and find that tomorrow, okay? Alright guys, your homework is everyone on that list above 12.